2 covers 0 and negative exponents. So what are 0 exponents? So this is any base raised to an exponent of 0, and the rule is that that base or that answer is going to equal 1. Okay, so x to the 0 equals 1. So let's evaluate these. M to the 0, well, as soon as it's 0, the answer is 1. Negative 2 to the 0, the answer is 1. Okay, it could be anything to the 0. It could be like x squared, y cubed, ab divided by whatever. And as long as the entire thing is raised to the 0, you should put m. The entire thing equals 1. Okay, exponents of 1. Any base raised to the exponent 1 equals the base. So b to the 1 equals b. 6 to the 1 equals 6. Let's go x cubed y squared z to the 4 all to the 1 will equal this right here, x cubed y squared z4. So it doesn't matter how ugly it is, any base raised to the 1 is that base. Okay, negative exponents. So we touched on this a little bit in 7.1, but any base raised to a negative exponent is equal to the reciprocal of the base raised to the positive exponent. So let's take a look. M to the negative 2. Well, we know that there's like the imaginary base of 1. So in order to get this negative 2 to be positive, we have to flip the number, so 1 over m, and then we can raise it to the positive exponent. Okay? So in a two-step like this, negative 2 to the 3 divided by negative 2 to the 7, well, let's take care of the division first. Okay, so we know that we subtract the exponents, and you're going to see this very often where when you subtract, and remember it's the first minus the second, okay, so it's negative 4. A lot of students will put positive 4, just simply subtracting the bigger number minus the smaller number, but it's the first number minus the second number, or the number in the numerator minus like the exponent in the denominator. Okay, so we have negative 2 to the negative 4, and this negative 2 is over 1. So we can flip that, 1 over negative 2, and we can raise it to the exponent 4. Okay, and c. We can collect these b's, and then we can collect the c's. So b to the 4 minus 6, c to the 2 minus 1. Okay, we get b to the negative 2, c. Since this b is to the negative 2, we can again, this b is over 1, we can flip that. So we're going to have 1 over b squared times c. Okay, you can rewrite this as c over b squared. Either one of these is correct. Okay, so let's practice. Example 1. Evaluate powers with 0 or negative exponents. Okay, so there's going to be a huge mixture here. So 3 squared is 9. But if we have 3 to the negative 2, like negative squared, then we have to flip and then raise it to the positive exponent. Okay, here's another thing. With this positive exponent, we can rewrite this as 1/3 times 1/3. And we get 1 over 9. So let's just compare these, 9 and 1 over 9. Okay, so it's that same number 9, but it's either in the numerator or in the denominator there. Okay, so what's 5 cubed? That's 125. And what about 5 to the negative 3? So like negative cubed. Okay, so first I would flip the 5, raise it to the 3. So our answer is 1 over 125. Okay, so compare those. 125, 1 over 125. 10 to the 4. When I think of tens, I think of 4 zeros. So like when we raise this to the 4, so this is 10 times 10 times 10 times 10 times 10. So you multiplied it 4 times. Okay, so the answer is 10,000. And for f, we flip the 10, we raise it to the 4, so it's 1 over 10,000. Okay, so we're starting to see patterns here. Negative 3 to the 3 is negative 27. And negative 3, let's flip this. 1 over negative 3, to the positive 3. 1 over negative 3 to the exponent 3 is going to be 1 over that negative 27. Okay, and remember this negative sign, it doesn't belong in the denominator or the numerator. It's actually saying negative of the number 1 over 27. 1 over 27 is a single number, and then we're taking like the negative of that. And here's a couple more for reinforcement. Okay, 2 over 3 to the negative 4. So let's write this as a positive in the exponent. We're going to flip the 2 over 3, it becomes 3 over 2, and that's to the 4. Okay, what this means is that it's going to be 3 to the 4 in the numerator and 2 to the 4 in the denominator. So 3, 9, 27, 81. 81 over 2, 4, 8, 16. 16. Okay, I threw in J and K because a lot of times when students run into this positive, like we're adding 6 to the 1 and then 6 to the negative 2, what happens is students end up using exponent laws, but you can't for this because there's a positive. So exponent laws only work for, and I'll put it in the bottom corner, multiplication, division, and power to a power. Okay, so what's 6 to the 1 is just 6. And what's 6 to the negative 2? Well, it's 1 over 6 to the 2. Okay, let's rewrite that. 6 plus 1 over 36. Okay, if we were trying to add these, we need a common denominator. Okay, so we have to multiply 6 by 6 over 6. 36 over 36, which is like a huge number. 6 times 36. We get 216. 216 over 36 plus that 1 over 36. So we're going to get 217 over 36. Okay, quite ugly, just simply because we cannot simplify first using exponent laws. Okay, 3 to the negative 1 is 1 over 3. Then we're going to add negative 3 to the negative 3. So let's go 1 over negative 3 to the 3. So we got here 1 over 3 plus or minus 1 over 27. Okay, and all I did with this negative was bring it up here. Okay, we have to multiply this by 9 over 9. 9, 18, 27. Yeah, so 9 over 27 plus 1 over 27, we get 10 over 27. Okay. All right, back to exponent laws. 1 over 2 to the negative 4, 2 over 1 to the 4. We don't even have to write that 1. Just 2 to the 4. 2, 4, 8, 16. Okay, here are some 2-steppers and 3-steppers. 5 to the 4 times 5 to the negative 3. When I have a fraction, I always do the top. So we're going to add those, 4 plus negative 3. And then I leave the bottom, or I do everything on the top and everything on the bottom, and then I'll collect them. Okay, so this is 5 to the 1 over 5 to the 4. Okay, again, this is division, so it's 1 minus 4. We got 5 to the negative 3, which is simply 1 over 5 to the 3, 1 over 125. Sorry about the room here. Okay, let's change colors. All right, 3 to the 6, 3 to the negative 2. So this is going to be 3 to the 6 plus negative 2, and that's going to be over 3 to the 12. So we get 3 to the 4 over 3 to the 12. Let's subtract those. We get 3 to the, what's 4 minus 12? 3 to the 8, and then you can just put that on your calculator. Oh, negative 8, sorry. So it's going to be 1 over 3 to the 8. And again, that you can put in your calculator. Okay. Let's do normal numbers. 4 times 6, 24. M squared times M, you just collect the exponents. 2 plus 1, M3. N squared plus N, so 2 plus 1 is 3 again. And that's over 24 M squared N. Okay, so these 24s cancel out. and they go to 1. These m's, so these divide, m cubed minus, like 3 minus 2 is just m to the 1. And then again for the n's, 3 minus 1 is just n squared. And that's your answer. Okay, now P, Q, and R, these ones we really have to focus on where the negative sign is and what it's attached to. Okay, so P. First, in BEDMAS, we do exponents. So let's bring this down here. Okay, and you can choose to do 4 squared, which is 16, or 2 times -1, like the actual exponent laws. I'm just going to stick to exponent laws right now. So 4 to the -2, because we got 2 times -1. Okay, again, bring this negative sign down. Let's flip the 4, and let's raise this to the squared. Okay, so I get 1 over 1, oh sorry, -1 over 16. 1 over 4 squared, and then we bring that negative down. Okay, Q and R. This 0 is connected to the entire bracket, so the entire bracket goes to 1. Now R, this 0 is only connected to the 6, so bring down the negative sign, and this 6 goes to 1. Okay, now let's look at a word equation. Okay, a radioactive material decays by 2 to the -1. Okay, so when we're looking at 2 to the -1, we're actually looking at 1/2 to the +1, which is just 1/2. Okay, so it decays to half of its original mass in 8 hours. Okay, so if we have a 200 milligram sample, how much of that 200 milligram sample would remain after 1 day? Okay, so we know 200 is going to be at time 0. Actually, let me move this over. I'm going to do this like in a chart fashion, and then I'll get into an equation. Okay, so this is going to be time. So it starts at, S is going to be for sample. It starts at 200 milligrams. Okay, and after 8 hours, it's going to be half. And after another 8 hours, it's going to be another half. So half of 200 is 100, half of 100 is 50, okay? And after another 8 hours, it's going to be 25, okay? So the answer for 1 day, well, there are 8, 16, 24. There's going to be 3 half-lives until 1 day. So there are 25 milligrams left after 1 day, okay? So if we're looking for 3 days, what we'd have to do is just extend this chart. So 24 plus 8, okay, and then plus 8, plus 8. But instead, let's actually use an equation. So let's call it the amount is the starting amount, 200. And what we're going to do is we're going to multiply 200 by 1/2 t times. Okay, so in 3 days, there's going to be 8, 16, 24, is it 32, 40, 48, that's 2 days. 24 is 1 day. Okay, so 1, 2, 3, 4, 5, 6, and then in the 3rd day, until the 3rd day, it's going to be 3 more, right? 48, 56, 64, and then 72, right? 72 hours, that makes sense. So there's going to be 6. So what we could do is just sub in 200, and then we can write 1/2 to the 6th. It's basically like doing 200 and take 1/2 of that, and take 1/2 of that, and take 1/2 of that. 1, 2, 3, 4, 5, oh, sorry, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, and we can write 1/2 9 times, but that's a little tedious. So we just write it 1/2 to the 9. And if we write that in our calculators, I'm going to get 0.390625 milligrams. And that's how much is left after 3 days.